Hello, 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 and welcome to, wow. I am always so surprised at my enthusiasm when it appears. Anyway, hello, welcome to another ramble with me. We are rambling about IEB May 2025, paper 1. Question 11. Consider the graph represented by the relation x is equal to negative y plus 1 times y minus 4 times y minus 7. And note that we're not calling it a function. Why? Because functions are either one-to-one or many-to-one, right? One output, what? One input can only have one output. You know, a certain input can only have a certain output. Many inputs can share the same output, but it's not a situation where one input can have this output or that output. But we see here with this curve that, for example, this input over here, x, could have that output, or even that output. So there's 3 possible outputs for this relation, depending on, if I put in this x, I could get this y, or that y. Right, so it is not a function, it is a relation. This is an example of a many-to-many relation. What do we mean by many-to-many? Many-to-one? Is it a many-to-one? What? How do I say one-to-many? One-to-many. Yeah. Because for a given output, any y value always maps to a single x value. So you don't have this y value also having a point over there that corresponds to another x. So I think this is a one-to-many relation. Hey, you know, sometimes I get so confused by the things I'm saying on this video, and then I just need to stop recording. Unfortunately, I can't pause recording. So when I do a video, I have to do it in one take. So only after I've recorded am I like, oh, you know, there was such a clearer way to explain this. But anyway, it's not important whether it's a one-to-many or a many-to-many. It's not a function. That's the most important thing. Anyway, so this is the relation. Then the graph cuts the y-axis at A, B, and C. Wonderful. Determine the length of AC. So essentially, we are trying to find these y-intercepts, and we know that they occur at x is equal to 0, y is equal to something, and likewise this one will be at x is equal to 0, y is equal to something. So that's what we're going to try to solve, is for which values of y do I get x is equal to 0. Hey, it's so weird talking about a relation and not a function, because hey, so used to x being input, y being output. But with this relation, it kind of feels like the input is y and the output is x. Hey, I don't know, man. Right, so thankfully, this is an equation where one side is 0, the other side has been factorized. So we know that if this times this times this is equal to 0, then that means either y plus 1 is 0, or y minus 4 is 0, or y minus 7 is 0. And the first one would imply that y is equal to negative 1. The second one would imply that y is equal to 4. And the last one would imply that y is equal to 7. So A, being the highest point, makes sense that its y-coordinate is 7. And C, being the lowest point, the lowest y-intercept, makes sense that its coordinates are 0, negative 1. And so therefore, so we would just say that here. So the coordinates of A are 0, 7. The coordinates of C are 0, negative 1. The more I try to make that look like a 1, the less it looked like a 1. Okay, right, and so therefore the length of AC, because this is a perfectly vertical line, we don't have to go through all the hassle of distance formula. We can just say, you know, it's 8 units, right, just minus the y coordinates. Right, so that's that answer. Next up, write the inverse of the relation above in the form y is equal to dot 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 dot. We know that to get the inverse, we swap the x and the y. So the inverse will be y is equal to negative x plus 1, x minus 4, x minus 7. So that would be a cubic graph that looks like this. Okay, and I know that because of that negative, and the x-intercepts would be negative 1, 4, and 7, right? So that would be the inverse function, and this would indeed be a function because remember we said function is either 1-to-1 or many-to-1. The most important thing is that for every input value, for every x, there's only one output value. So if you look all across your curve, we don't have a situation where, for example, for this x value, there's an output there and there's an output down here somewhere, right? All of them, all of the x values have exactly one possible y value. And so that is now a function, right? So others would say the what? Vertical line test. So if you were to imagine running through from left to right and looking at how many times does this ruler intersect the curve at any given point, we see that at any given point it only intersects the curve once. So that's how we know that this is a function. This is how we know that for every x there's only exactly one y value, right? Next up, hence determine the length of mn if m is the turning point of the relation and n lies on the y-axis such that mn is perpendicular to AC. So we know that mn is basically then parallel to the x-axis. So these two have the same not x coordinate, the same y coordinate, for instance. So that's what this is telling us, right? So like I said, we know that the inverse is a cubic curve that looks like this, and the mirror image, if we can call it that, of m. So m is the turning point between C and B, between negative 1 and 4. So it would be this guy over here. This would be the twin of m. You can call him m light, m dash, right? So if we can find the coordinates of this turning point, then we will be able to find the coordinates of m, right? Right. Ooh, I haven't tested how my singing sounds with this little Hong Kong microphone that I'm using lately, but not bad. So sincere apologies if it sounds worse than usual and it is piercing your eyes, your ears, right? So this is the inverse function, and this is what the inverse function looks like as discussed. So I'm actually going to move this here, right? So yeah, like I said, this is the mirror of C, this is the mirror of B, this is the mirror of A, right? And so M is mirrored by this turning point. So we just need to find the coordinates of this turning point, switch them around, and then we have the coordinates of that turning point. And then from there, it won't be hard to find the coordinates of n, because we know that the coordinates of n are 0 and whatever the y coordinate of this guy is. So how do we find the first derivative of this guy? We are going to need to multiply the brackets out, and then we will find the first derivative and all of those fun things. So let's go ahead and do that. I'm going to do the first two brackets. So that will be x squared minus 4x plus 1x minus 4 times x minus 7. And if we go ahead and multiply, well, no, let's simplify this first. Whoa! Minus 4x plus x is minus 3x. Right? And then let's multiply. So we'll have minus x cubed, yeah, and then minus 7x squared, and then minus 3x squared, and plus 21x. Then we have minus 4x, and a need for shrinking or moving. Right, so we just did that one, and then we're going to do minus 4 times minus 7, which is plus 28. Right, let's simplify further. So we have minus x cubed minus 7x squared minus 3x squared plus 21x minus 4x plus 28. And then we multiply our negative 1 in. So we've got negative x cubed plus 10x minus 17x minus 28. And then now the first derivative, dy dx, is going to be minus 3x squared plus 10. Hey, wait a minute. Okay, sorry. I missed it. My squared there. So minus 7x squared minus 3x squared is minus 10x squared. There's no reason for that squared to disappear. Skis. So first derivative will be minus 3x squared, and then for the next term we'll have plus 20x and then minus 17. And then from there we want to see where is this equal to 0, because that will tell us where are our turning points. So let's just see here. If I times these two, I'm going to factorize. You can use a quadratic formula. You can complete the square if you feel like it. Minus 3 times minus 17 is positive 51. And then the question is, are there any factors of 51 that add up to 20? And it's literally 3 and 17. So, I don't really like factorizing when the coefficient of this guy is negative. It's not a crime, but I just don't like it. Right, okay. So we'll have 3x times x, which will give us this term. And then 17, thankfully, is prime. So that's a 1 and a 17. And remember that we said this middle term is going to be made up of a 17 plus 3. Well, so in this case, it will be minus 17 minus 3. So I need this multiplication and this multiplication to give me a minus 17 and a minus 3. So this will be minus 1 and this will be minus 17. So that I get my minus 3 here, minus 17 here, and then when I add them together I get minus 20. And when I times these together I get my plus 17. So therefore, either 3x minus 17 is equal to 0 or x minus 1 is equal to 0. And so 3x, when 3x is equal to 17 and x is equal to 17 over 3, or in this case x is equal to 1. So our two turning points occur in that way. 17 over 3 is like 5 2/3. So let's go back to our rough sketch. So this guy will be the 1 and something, and this guy will be the 17 over 3 and something, right? And of course you could also test which one is the local max, which one is the local min, by finding the second derivative, so 6x minus 20, and then subbing in each value and seeing, okay, when I sub in 1, so 6x minus 20, if I sub in 1, I get 6 minus 20, which is minus 14. So the value of the second derivative when x is equal to 1 is negative, meaning that my graph is concave down at that point. Hey, does this agree with... Hey, guys, this thing was just catching stompies. Sorry. The first derivative is not this guy, it's this guy. So let's actually just do a proper job of it and stop being fly-by-nights. Okay, so, right, we know that the first derivative is that. So then the second derivative, how do I write this now? Is it like this? Come on, Google. Give me a moment. How to write second derivative. Yes. Don't doubt yourself, kids. Believe in yourself. So the second derivative here would be minus 6x plus 20. So then when x is equal to 1, for example, the second derivative would be minus 6 times 1 plus 20, which would be 20 minus 6, which is 14, and that is a positive number, meaning that at that point, when x is equal to 1, the graph is concave up. So x is equal to 1 would be a local minimum. And if you were to do the calculation for x is equal to 17 over 3, so negative 6 times 17 over 3, hi man, what is that now? What abomination is this now? Yo. Hi. Right, plus 20, you find that is now a negative value, meaning that when x is equal to 17 over 3, the graph is concave down. So we have a local max at that point. Right, so this agrees with the sketch that we drew. Right, so that means that our m dash has coordinates 1 and something, so then we need to find the something, and we find that by substituting into the original function, or the function of the inverse. Right, so let us do that. So when x is equal to 1, y will be equal to minus 1 plus 1, 1 minus 4, 1 minus 7. So this will be minus 2 times minus 3 times minus 6. And if we times them all together, we have minus 6 times minus 3 is positive 18, times 2 is 36, times negative 1 is negative 36. So therefore, the coordinates of our m dash is 1 and negative 36. Right? And negative 36. Okay, and so therefore, the coordinates of m will be these two flipped around. So actually I want this diagram. And I want you to fit here. You. Right. So the coordinates of m will therefore be negative 36 and 1. Meaning that the coordinates of n will be 0 and 1. Did it even matter the y coordinate? not really. uh, but anyway, it was a freebie. It was there for the taking and we took it. Right, so the question is, what is the length of MN? And once again, because this is a nice, perfectly horizontal line, we can just say the length of MN will be the bigger x coordinate minus the smaller x coordinate, which will be 36 units. Right, so not a terrible question, just a weird looking one. Let's see how we did. Question 11. We have the length of AC is 8 units, indeed. The inverse of the relation is very simply exactly what I wrote. And then lastly, we find the coordinates of M dash. The way that I did it is valid, is correct. And then we substitute our value into the original, what, guys, you know what, yeah. MN is 36 units. Right, I hope you had a ball with this one. I hope that it surprised you pleasantly. And if you didn't have a ball and it did not surprise you pleasantly, go through it again, build your confidence, and see for yourself that yes, it looks foreign, but actually you know what you're doing. Believe in yourself. Alrighty, see you next time.